Yes, sir. Oh, this is SARS context. SARS context. Let it be. I, you can switch off these lights and switch on the last ones. Last one. Oh, I know. Yes, sir. Yes, sir. EW. Right. Now tell me, sir, whatever the topic you want, you ask me, I will complete the topic. First is Spencer. Right. So in GOC, this determining acidic strength is a important concept, right? First, how to calculate the acidic strength. If you take any acid or alcohol or any acidic hydrogen which is between two withdrawing groups, means, for example, I have taken CH3, C double bond O, CH2, C double bond O, CH3. What type of group this is? C double bond O, C double bond O. If carbon connected to more electronegative atom via multiple bonds, then this electron cloud always try to move towards oxygen. We call such a group as minus M group. What do we call it as? So, or electron withdrawing group. Clear? For example, say this. I have taken C double bond O. The meaning of this is, here I have one carbon chain. On that carbon chain, one carbon is connected to more electronegative atom via multiple bonds. Then I call this as electron withdrawing group or minus M group. Clear? Any questions in it? What about this one? NO2. Can I write as electron withdrawing group or not? C triple bond N, cyanide group. Correct? COOH, acid group. Correct or not? So any element connected to more electronegative atom via multiple bonds, then definitely that group is called as electron withdrawing group. The electron withdrawing groups are indicated by minus I or minus M. If they are connected through multiple bonds, then I call them as minus M. If they are not connected with multiple bonds, then I call them as minus I. Clear? Any questions in it? Now say this. I have taken CH3, CH2, single bond, chlorine. Here, carbon and chlorine are connected to each other via single bond. Correct? Now, do this chlorine is more electronegative atom or not? This is more electronegative atom. Electronegativity is indicated by a symbol chi. So, electronegativity of chlorine is 3. Electronegativity of carbon is 2.5. Which is more electronegative atom? Then these electrons will be pulled towards chlorine or not? If they are pulled towards chlorine, you will get partial negative and you will get partial positive or not. Now over this carbon chain, electron density is increasing or decreasing because of chlorine. That's why I call this as electron withdrawing group. And I call it as minus I group. Reason? It is operated over only through single bond. Any question? Right? Or in simple words, if a more electronegative atom is connected, then I call it as minus I group. If that more electronegative atom is connected to another more electronegative atom via multiple bonds also, then minus M. Right? For example, CH3, CH2, C triple bond N. Correct? What is hybridization of this carbon? Because it is forming only single bond, sigma bonds. What is the hybridization of this carbon? So percentage S character is 50. Here percentage S character 25. As percentage S character increases, so which is more electronegative carbon? Correct? If this is more electronegative carbon, can I call it as minus I? Correct or not? Response, sir. At the same time, it is connected to more electronegative atom through multiple bonds or not? Therefore, it is also. So this is minus I group as well as minus M group. But anyhow, we call it as electron withdrawing group or not? Because it is trying to pull electron cloud from carbon chain again. Are you able to understand? Any questions in it? I am taking one more example. CH3, CH2, NO2. Now tell me, what type of group this NO2? Is it electron withdrawing group or not? Definitely it is electron withdrawing group. So definitely it is electron withdrawing, no doubt. So electron withdrawing group will decrease electron density over carbon chain. Now do this nitrogen is more electronegative than carbon or not? That means is it minus I group or not? that atom is connected to more electronegative atom via multiple bonds or not? So it is also minus M group or not? So it is electron withdrawing group, right? And it is showing minus I effect as well as minus M effect. Clear? Any questions in it? Right? If this atom is more electronegative, then it is more minus M group. If this atom is more electronegative, then it is more minus I group. Simple. Correct? Respond, sir. Any questions in it? No. Now, can I say these two groups are electron withdrawing groups or not? These two are electron withdrawing groups or not? Respond. Right? What these electron withdrawing groups do? They will decrease electron density over carbon chain. Now tell me, among those three carbons, on which carbon electron density decreases more? Exactly, middle part. Right? Correct or not? So what we call this carbon as? We call this as active methylene group. What we call it as? Active methylene group. Why I call it as active? Electron density over that carbon decreases more. If electron density on this carbon decreases more, what this carbon tries to do? As this carbon is electron, I am talking about this active methylene group, CH2 group. I wrote that CH2 here, right? These two groups are pulling electrons. Then this carbon gets electron deficient. Then this carbon tries to pull these electrons towards itself or not? Correct or not? Because these two groups are pulling electrons. Then electron density over this middle carbon decrease. Then what that carbon do? That carbon also tries to pull electrons from hydrogens present over it. Correct? If it tries to pull the electrons out, this hydrogen tries to go out as H plus or not? If it is trying to go out as H plus, we call it as acidic or not? Right? Are you able to understand? As this is capable of producing H plus ions, we call this carbon as active methylene group. Clear? Any questions in it? So hydrogens over that carbon are more acidic, or simply I will write acidic hydrogens. It is having acidic hydrogens. Will you understand, sir? Right? Means it is trying to lose H plus ions, or indirectly can I say it is trying to bear negative charge? Or it is trying to lose H plus means it is trying to get negative charge. Means over this carbon, negative charge is stable. Respond. Correct or not? So try to bear or try to get negative charge. Okay. If it is capable of giving H plus ions, can I say it will have Ka value? An equilibrium constant Ka. For acids, you will calculate Ka, na? So it will have Ka value. Do that Ka value is very negligible or Ka value is reasonable now? Reasonable because it is acidic. If a Ka value is reasonable, what is pKa value? Low. Correct or not? So I am writing the same. In case of strong acids, Ka value is high and pKa is low. Because pKa value is nothing but equal to minus log of Ka. Correct? pK value is negative logarithm of Ka value. Any questions in it? Right? No. Means what I am trying to calculate here or what I am trying to compare here. I will try to compare Kas or I will try to compare pKs. Clear? So if I give you two compounds, and if I give you pK values of those two compounds, now how you will say which is acidic? Whichever is having lower pKa, it is stronger acid. Whichever is having higher pKa, weak acid. Or if I give Ka values, higher Ka is strong acid, lower pKa is strong acid. Any questions in that? Right? Now see this, point 1. Compounds having active methylene groups are more acidic. Accepted. Is this example of such compound or not? Compound having active methylene groups are acidic. Correct? Response, sir. Now, second, CH3, CH2OH. Here, observe this hydrogen. This hydrogen over more electronegative atom, correct or not? That hydrogen is present on more electronegative atom or not? What more electronegative atoms try to do? If that oxygen tries to pull electrons, H has to go out as. Means is it acidic or not? So hydrogens over more electronegative atoms are also acidic. Correct? Similarly, is these hydrogens are acidic or not? Do these hydrogens are acidic or not? Correct? Do these hydrogens are acidic or not? Why these hydrogens are acidic? Those hydrogens are present over sp hybridizer carbon. As a percentage S character increases, as percentage S character increases, what happens? Electronegativity increases. If hydrogen is present over electronegative atom, then it is acidic. So obviously it will be acidic. Any questions? Right? What about S double bond O double bond O OH? Do this hydrogen is acidic or not? Why? It is present on more electronegative atom. Correct? What about this acid, this hydrogen? Acidic or not? Acidic or not? This is called sulfonic acid. This is called carboxylic acid. We call this as inorganic acid. I call this as organic acid. Generally, inorganic acids are mineral acids. Why I call it as mineral acid? What are minerals which are available in aquifers? They are all called as minerals. Sodium sulfate is a mineral or not? From sodium sulfate, can I prepare sulfuric acid or not by doing electrolysis process? So sulfuric acid can be prepared from minerals or not? So I call it as mineral acid. So the acids which can be generated from minerals are from the compounds which are available from earth crust. We call all such acids as mineral acids. 99.99% cases, all mineral acids are stronger acids than organic acids. Very simple statement. All mineral acids are stronger acids than organic acids. Clear? Means all sulfonic acids are more acidic than carboxylic acid. Any questions in it? Clear or not? Right? Now tell me, what is HI, HBr, HCl, HF? What are they? Can I call them as mineral acids or not? Can I call them as mineral acids or not? Right? So whether these acids are more acidic or not? Respond, sir. Already we know the acidic character of HA, HBr, HCl, and HF. HF is considered as weak acid. HA is very strong acid because of lower bond dissociation energy. Correct? So I am not bothered about it. In general, mineral acids are more acidic than carboxylic acids. Now, very, very important statement. I have taken CH3, CH, chlorine, COOH. Do this hydrogen is acidic hydrogen or not? Correct. What type of group chlorine is? Electron withdrawing group. So is it minus I group or not? What this minus I group do? It will pull electrons. If it pull electrons, can this oxygen also can pull these electrons more strongly towards itself and H plus can come out more easily? Means what these minus I groups do? These minus I groups will enhance the acidic nature of carboxylic acids or not? Yes, sir. చెప్పండి లేనట్టే అస్సలు లేనట్టే జీరో వాళ్ళని ఏదైనా స్కూల్ కి ఎస్బీఓ లేదా కేఎంఆర్ మనకెందుకే వస్తుంది కానీ అక్కడే క్లాస్ స్కూల్లోనే పెట్టి రైట్ సో this minus I group is enhancing acidic nature or not? Correct? So I am writing that statement. Minus I, minus M groups increases acidic nature. Then what about plus I and plus M groups? They will decrease acidic nature. I call these minus I, minus M groups as electron withdrawing groups, EWG. Then what I call these groups as electron donating groups. Correct or not? Correct or not? Now, how to identify the group is electron donating group or not? If a connected atom is less electronegative, or if a connected atom have lone pair of electrons over it, then they are considered as electron donating groups. Clear? Now, for example, CH3, CH2, OCH3. Do oxygen have lone pair of electrons or not? Now tell me, what type of group this OCH3 is? It can donate electrons because of lone pair electrons present, right? So can I write it as a plus M group? On the top, oxygen is more electronegative than carbon. So oxygen is more electronegative than carbon or not? Then minus I. If any element is more electronegative than carbon, then what do you call it as? Minus I group or not? If it is having lone pair of electrons, then I call it as. So it is minus I plus M. Always mesomeric effect dominates inductive effect. Means M always dominate I. Clear? Mesomeric effect always dominate inductive effect. Clear? Any questions in it? Response, sir. Right. Now, I will keep on giving some examples. You need to tell me what type of groups they are. Clear? Among these two, which is more acidic? Why? Why? What type of group it is? What type of group it is? Okay, withdrawing group only. Minus M effect or not? Correct? Minus M. So minus I effect is there or not? Hey, we discussed this condition. Inductive effect operates only up to 3 sigma bonds. Here, this is electron withdrawing group, more electron into atom. But 1 sigma bond, 2nd sigma bond, 3rd sigma bond, 4th sigma bond, 5th sigma bond. Right? It is effective only up to maximum of 4 sigma bonds. Beyond that, it doesn't have more any effect. So minus effect is there, but it is very correct. But minus M effect is there. Correct or not? Response, sir. So which is more acidic among these two? Right? Yes, sir. Chlorine is a plus M minus I. Plus M as well as minus I. No, obviously plus M slightly dominates.
So then chlorine.
Because chlorine have 3p, lone pair of electrons in 3p orbital. We cannot call it as, that's why in case of benzene, what I told you, it is ring deactivating but orthoparadidating. Correct? Only in case of halide. Any questions in it? In that way, if I keep on giving different compounds, can you give acidic nature or not? Right? Response, sir. No questions now. Now I am deleting everything. All this is theory, nothing nonsense. Right? Now I keep on giving questions. You need to keep on giving me the answers. Over. Basic idea is done. Right? Tell me acidic nature of these four. A, B, C, D. Give the order of acidic nature. So, which is more acidic? D greater than, C greater than, B greater than A. Correct? Correct or not? Because here chlorine is minus I. Cyanide minus I minus M. Nitro minus I minus M. But among these two, which is better minus M group? NO2 is better minus M group. Reason? Here carbon is connected to nitrogen. Here nitrogen is connected to oxygen. Oxygen is more electronegative than nitrogen. Na? Here nitrogen is connected to oxygen. This oxygen is far more electronegative than carbon, which is connected to nitrogens. Na? You are talking about nucleophiles, man. We don't care about nucleophiles or anything. We are talking about whether they are able to pull electrons or not. Over. Respond, sir. Any questions in it? Respond. Yes. This is how many times we discuss this electronic effects. At least this is 20th time, man. Again, you are asking. Huh? How to identify minus M groups? How to identify minus M groups? If any element connected to more electronegative element via multiple bonds, then it is minus M group. Cut off. Correct? If any element connected to carbon chain having lone pair of electrons, plus M. If any element is more electronegative than carbon chain, minus I. Response. Over. Plus I. How to identify plus I group? If more number of carbons present over a chain, then it is plus I. If it is having a negative charge, plus I. If it is having positive charge, minus I. Correct or not? Right, sir. Why it came? Now, sir, one more example, please. Now, sir, among A, B, C, D, which is more electronic? Which is more acidic? Why? Why D? Compare C and D. Right? Why, sir? Here minus I is there. Here over this carbon, minus I is there at the same time. Correct or not? Here, here. So which is more acidic? C. More acidic than. More acidic than. Correct. Any questions in it? Right? This idea is enough to solve all questions of acids. Okay, ma? Now I am talking about these groups which are present over benzene ring. These are all open chains. No? I don't want open chains. I want to compare if they are present over benzene ring. Right? Observe this. What we call it as benzoic acid. Now, sir, among these four, which is more acidic? All are benzoic acid derivatives, right? So, which is more acidic? Hmm? Because of ortho effect. You can use learned that separately, right? Forget about ortho effect. If you don't know ortho effect, which is more acidic? Reason? In all other cases, plus psi effect is there. On the top, positive hyperconjugation is also there. What is hyperconjugation? Okay, Baker-Norton effect or no bond resonance. What is it means? Alpha hydrogens to sp2 hybridizer carbon involved in hyperconjugation. Correct? See this. Do this carbon is sp2 hybridizer carbon or not? Next carbon is called alpha carbon. On that carbon, if you have hydrogens, then those hydrogens involved in hyperconjugation, also called as Baker-Norton effect, also called as no bond resonance. Right? Correct or not? So, because of positive hyperconjugation, what it will try to give? It will give electrons. Means what it will try to do? It will increase electron density over carbon chain. Means from here H plus cannot go out. Correct or not? Respond. Any questions? And one more thing. All the types of mesomeric effect or hyperconjugations do not operate yet. Meta position. Correct. Electronic effect. Only inductive effect will operate at meta position, but not mesomeric effect or hyperconjugation. These two effects will not operate yet meta positions. I am repeating again, sir. I am repeating again. See this. I am taking aniline, NiH2, nitrogen have lone pair of electrons. Aniline or not? This is aniline. What type of group nitrogen is now? Plus M group? Correct or not? It can donate lone pair of electrons now, so it is plus M group or not? If that plus M effect is observed in benzene ring, I call it as plus R resonance. If it is in open chain, we call it as mesomeric. If it is present on benzene ring, we call it as a resonance. Okay, let it be. We will write as plus M only. Right? What type of effect it will show? Plus M effect it will show. If it is present on benzene ring, we call it as positive resonance. Clear? Correct? Can I call this as minus I group also? Why? Because nitrogen is more electronegative than carbon. That's why it is minus I as well as plus M. When both are operating, which will always dominate? Plus M dominate. That's why we don't care about. Clear? Now, if it is donating electron cloud, what happens to this pi bond? If it tries to move away, correct? Response, sir. Means I can get double bond NiH2 and you will write positive charge. Why I'm writing positive charge? Because nitrogen donated it lone pair. So electron density over nitrogen decreased, so positive charge. Then this pi bond moved away, you got that negative charge here, correct? Correct or not? Now, next step. I am trying to move this here and this here. Possible? Possible or not? I am doing that again here like this. Resultant of all these forms will be written as. So that will be written like this, correct? That's why we'll write as a ring. Correct, sir? Respond. Are you able to understand why I have written like this? Right? So can I write what is the charge developed over nitrogen? +1. And what is the charge developed over the carbons? If you observe all the structures, I got negative charge over this carbon, and this carbon. Correct? Correct or not? You never got negative charge over these two carbons. Correct, sir? Observe all the structures. Observe all the structures. We never got negative charge over those carbons or not? Respond. Means if we have any substituent over benzene, if we have any substituent over benzene, what we call this position as? What are the names of those positions? This position is called ipso. This is called ardho. This is called meta. And this is called para. Right? So due to plus M, that effect is not seen at which position? Meta position. That's why what I am saying, mesomeric effect do not operate at meta position. You are getting, because of that plus M group, you are getting negative charge over at ardho positions and para positions. Correct or not? But this is again meta or not? This is again meta. And what about this one again? Ardho. Respond, sir. Respond, sir. So mesomeric effects do not operate yet meta position. Are you able to understand the meaning of it? Why? What we call all these forms as? All these forms are called as canonical forms. Okay, resonating forms, right? And we call this one as resonance hybrid. I will call all these forms as canonical forms. Will you accept or not? Correct? Any questions in it? Right? Now, what is the possibility to get negative charge over this carbon? How many structures I have? Total, I have 5 structures. 5 canonical forms, correct? In that 5 canonical forms, I am getting negative charge in 3 structures. Correct? And I am getting positive charge also only in 3 structures. Right? In all the cases, I am getting positive charge over nitrogen alone. Correct? So that's why, can I keep a positive charge over this nitrogen in resonance hybrid form or not? And negative charge over this position I will place, over this position I will place, over this position alone we will place negative charge. In remaining carbons we will not place. Correct? How much negative charge I am getting? -1. -1 is the resonating charge obtained in all the canonical forms combined. So can I write that as -1/3? Sponsor. Possible or not? -1/3 here, -1/3 here, -1/3 here. Overall, what is the net negative charge? -1. Overall, what is the net positive charge? +1. Clear? Okay. No, I will not confuse you. Let it be like this. Leave it. We will not write anything. You will understand now if I write like this. Let it be like this. Don't think too much. Clear? So what you understood from here? Mesomeric effect or resonance effect do not operate yet meta positions. Clear? Any questions? No. I have taken CH2 plus group. I have taken CH2 plus group. I am taking NH2 group here. And I am studying about positive charge of carbocation. I want to check which carbocation is more stable among all these 3, where it is more stable among these 3, which is more stable structure. Which is most stable? Benzocation. Benzyl, no? On benzene ring, if you have a carbon, then that carbon is called benzyl carbon. On that carbon, you have positive charge. That's why it is called benzyl carbocation. Among these 3, which benzyl carbocation is more stable? Why? Correct. So it donates. So it is a plus M, no doubt. At the same time, it is -I also. Correct? Correct or not? So it is donating electron cloud. If it donate electron cloud, what happens? Electron density moves towards carbon or not? If electron density is moving towards carbon, what happens to this net positive charge? Decreases. Then stability increases. Correct? Now here, only -I. Plus M do not operate. Reason? For that NH2 group, CH2 group is at meta positions. So its effect is not operated at meta. Now what about last case? Plus M is there, but -I is weak. Reason? It is 4 bonds away. So minus effect do not operate. What -I effect do? Because of -I effect, what happens? Electron will be pulled. -I group means it will pull electrons. If it pull electrons, what happens to charge? Positive charge increases. If it is a donating electrons, what happens to positive charge? Decreases. If a positive charge decreases, the stability increases. In any case, if a charge decreases, the stability increases. In any case, if a charge decreases, stability increases. Now, among these 3, which is more stable? If I consider it as A, B, C. Which is more stable? Yeah? No way. C is more stable than A is more stable than B. Why I gave C? In case A and C, in both cases, plus M is operative or not? Do plus M effect is distance dependent or not? So irrespective of distance, mesomeric effect operates. Correct or not? Yes or no? So plus M is common in A and C. Then which is measurable, which is comparable now? Minus A effect. Where minus A effect is more? A. In C option, minus A is weak. Correct or not? Response, sir. You students are able to understand or not? Huh? Response, sir. Any questions in it? Over. Stability order. Right? Now I am giving one more example. Now, sir, in these three, check the stability order. Among these three, which is more stable? A, B, C. Why? What is CH3 group? Plus I, and also positive hyperconjugating group. Plus M. Positive hyper, that mesomeric effect is because of hyperconjugation. Correct? What is hyperconjugation? sp2 carbons. Next carbon is called alpha carbon. On that carbon, if we have hydrogens, we call it as alpha hydrogens. Alpha hydrogens involved in hyperconjugation. Right? Now, in this case, coming to this case. Now, here, what is the effect? Only plus I, sorry, plus I. Correct? Hyperconjugation do not operate. Reason? Meta. Now here, plus I is weak because it is distance dependent, and positive hyperconjugation operate. So which is more stable? A more stable than C, more stable than B. Over. One more example I am giving. If you understand this, then you can give stability or acidic nature of acids more easily, right? Now among A, B, C, D, which is more stable, sir? Among A, B, C, D, which is more stable? Hmm? Why? Correct. What I told you. This is the carbon next to sp2 hybrid. This is sp2 hybridized carbon or not? Next carbon is called alpha. Over that carbon, whatever hydrogens are present, they are all involved in hyperconjugation. How many hydrogens involved in hyperconjugation? 3. Next carbon, 2 only. Next carbon, 1. In last, no hyperconjugation. But which is good plus I group, which will donate electron cloud through inductive effect. D. But what I told you, among inductive effect and hyperconjugation or plus M effect, which will dominate? Hyperconjugation or plus M effects always dominate. So which is more stable? Yes, sir. A greater than, B greater than, C greater than D. Response, sir. Any questions further? Right? Clear? Based upon this idea, you can solve infinite problems. Infinite problems. Do you have any reference book with you? One minute. You are solving means MS Chauhan. Then I will solve Himanshu Pandey. Solving modules is nothing, man. Everyone will solve in modules. Throughout country, out of 1 lakh people enrolled in Akash, 10,000 people will solve modules. Hardly 100 people will solve beyond modules. So who will be top rankers? Only those 100 will be the top rankers, like this. Right? Okay. Let us see. Please. Okay, listen. So first I will go for GOC, yeah? 1 to 68. Isomerism is that easy concept. Right? Best question. Now see this. First we will solve level 1 questions, huh? Start. First question, sir. Which of the following belongs to plus I group? D, yeah? What about A? Minus I and plus M. Reason? Oxygen have lone pair of electrons and oxygen is more electronegative. Correct? Correct or not? So this is minus I group and plus M group. What about this one? Same, minus I plus M. What about this one? This is COOH now. Minus I minus M group. What about this one? Plus I plus M group. Instead of plus M, I am writing hyperconjugation because that plus M is because of hyperconjugation. So what is the answer? Option D. Response, sir. Come to next question. Strongest minus I group. No. No. I don't know. Array, one answer, okay, accepted. 2 times you corrected. Third time, if you corrected, if I say yes or no, you will give the answer. Over. So I don't know. A, why? Array, compared to neutral atoms, if any atom have positive charge, means it is more electron deficient. I am having positive charge means I don't have electrons. That's why I have positive charge. If I don't have electrons, I will pull electrons more effectively. So compared to fluorine, remaining all the 3 have positive charge. Remaining all the 3 will pull electrons effectively. Correct? Yes or no? Now, in that also, among sulfur and nitrogen, which is more electronegative? Nitrogen. So definitely nitrogens are more effectively pull electron cloud. Accepted. Now, again, 2 nitrogens are compared. Among these 2 nitrogens, which is better minus I group, which will pull electrons more effectively? A or B? Why?
No, I
am talking about inductive effect. Why you are bringing hyperconjugation? Read the question. Whether they are comparing only inductive effect or do they are asking which is more electron withdrawing group? Whether they are asking which is more minus I group or whether they are asking which is more electron withdrawing group. Means only compare inductive. Inductive effect operates only through sigma bonds. Inductive effect doesn't consider about lone pair of electrons or hyperconjugations or anything. Response, sir. Now, yes, sir. You are saying something.
Second option is.
Second option only, yeah. Now listen, sir. One thing is confirmed. T is lowest than C, lowest than ARB. Now I am comparing first A. Nitrogen have positive charge, CH3, CH3, CH3. Next one, nitrogen have positive charge, H, H, H. Correct? What type of group CH3 is? What is it? Plus I. Plus I group, what it will do? It will give electrons. Right? So it will push electrons towards nitrogen. Correct? Now, one more thing. Among nitrogen, carbon, there is electronegative difference. Among nitrogen and hydrogen, there is electronegative difference. Where electronegative difference is high? Nitrogen and hydrogen. Electronegative difference is high. If electronegative difference is high here, because electronegativity of carbon is 2.5, electronegativity of hydrogen is 2.1, correct? Electronegativity of nitrogen is 3 or less than 3. Okay, let it be 3. Correct? Now, where electronegative difference is high between nitrogen carbon or nitrogen hydrogen? If electronegative difference is high, these electrons will be close to nitrogen. Response, sir? Correct? If they are close to nitrogen, what happens to electron density over nitrogen? Increase or decrease? If that electrons are close to nitrogen, do electron density over nitrogen increase or decrease? Electron density? Then what happens to positive charge? If the positive charge decrease, whether it is able to pull other electrons effectively or less effectively. That means which is more minus I? NCH3. Reason? Yes.
The first thing is
Correct.
donate electrons.
Through what? Hyperconjugation. Because of, yes, no doubt, it is plus I group. No doubt, it is plus I group, accepted. Now, if you are good donor, I also have to accept. You are giving, I need to accept. Means if we have more difference between us, the more you donate, the more I will accept. Correct or not? You are a donor, accepted. But we don't have much difference, man. Then you are donating electrons. Do that electrons has to flow to me or not? Correct? Where that electrons will flow towards nitrogen effectively? That is the question.
Sir, they are should be
But electron withdrawing is for the total group or between atom and another atom. So the total group means we need to consider the total set. Here, methyl group is for sure plus I effect, no doubt. For sure, methyl is plus I effect, accepted. So methyl is trying to give electrons. If I have deficiency, whatever electrons you are donating, that electrons will come towards me more effective. Means we should have more electronegative difference between us. But electronegative difference between nitrogen and carbon is less. If they have less electronegative difference, do the electrons will come or not? No. No doubt CH3 is good plus I. Right? So what should be the answer now? So which is strongest minus I group? First option. So A greater than, B greater than, C greater than D. Now I am modifying the question, sir. Listen carefully. Which of the following is a strong electron withdrawing group? Observe the difference between minus I group and electron withdrawing group. Which is a strong electron withdrawing group? Then becomes B option. Why? Because of hyperconjugation. Because of inductive effect, electrons will not flow. But because of hyperconjugation, electrons will flow. Correct? Because of hyperconjugation, if electrons flow, electron density over nitrogen decreases more. Hey. Density increases, positive charge decreases. So go. Hyperconjugation means, listen, again I am repeating. Hyperconjugation means, observe this case. This sigma bonded electrons, ability of that sigma bonded electrons to shift is called hyperconjugation. Clear? More hyperconjugated hydrogens, more effectively electrons will shift. Oh. Clear? Next case, sir. Which is the strongest acid? Yeah. Why? Then why not D? Why not D? D is having hydrogen on more electronegative atom. So for sure, A and D, among these two only answer is there. Now I give the answer. If a hydrogen is present on more electronegative atom, it is more acidic. If a percentage S character increases, then also more acidic. Right? For sure, these two are acidic compounds. A and D are more acidic. That is accepted for sure. 100% sure. Now I want which is more. Here we cannot blindly rely on theory. In that cases, what we have to do? We need to check experimental data. So by doing experiment, we will dissolve them in water or we will dissolve them in acetic acid and we will compare whether they are able to give H plus or not. That's why we need to compare pKa values. What we call it as pKa value. That's why if you see that notes which I have provided to you earlier, where in which chapter I have given that values? Electronic effects. Huh? See this one. Where is it? Listen. Here we discussed about inductive, all types of effects, all types of electronic effects, man. Plus I, minus I, plus M, minus M, hyperconjugation, reverse hyperconjugation, plus C, minus C, inductomeric, all this are done already, right? Now we are discussing about this is mesomeric effect, hyperconjugation is already done. Inductomeric effect, electromeric effect. Just now we discussed this idea, carbocation stability. Aromaticity head. Hey, where man? Here. Observe. Acidic nature, what I am doing. If you see everywhere, when I am comparing acidic nature, what I am comparing, sir? Right? Theoretically, to some extent only I can compare. In few special cases, I cannot compare that. Then I will depend upon experimental data. Right? Those examples we need to. I don't have any choice. Clear? Now, what I am comparing about here, note. Read that note carefully. What I have written. Carboxylic acids are more acidic than methanol, which is more acidic than water, which is more acidic than alcohols, which is more acidic than alkynes, means percentage character, which is more acidic than ammonia, which is more acidic than alkane. Now in this question, what they are asking about methanol, alcohol, and alkynes, which is more acidic. Clear? Response, sir. So what should be the answer? Now, listen. Again, here I want to give one more data. Till 1952, in that book, what I have written? Among alcohols, which alcohol is more acidic? Among these alcohols, this is methanol, correct? Water. And this is ethyl alcohol, propyl alcohol, and so on. Among all those alcohols, which is more acidic alcohol? Methanol. Among methanol and water, which is more acidic? Methanol is more acidic than water. This is believed to be correct till 1952. In 1952, they proved it as wrong. Right? Then they modified it. In 2012, IUPAC have given a circular that throughout world it has to be modified. Right? Now, among water and methanol, which is more strict, means water only. But in all our books, we are still following methanol more strict than means we have to follow it only. Even though it is reason, it will take another 100 years to modify our books. Right? But I'm giving you, if someone questions you, hey, how methanol is more acidic than water, then we can say, no. Water is more acidic than methanol. If they ask, show me in a book, books are, for this, there is a reason. We are calculating pKa value of water by using ionic equilibrium chapter. Do you remember? Remember or not? In ionic equilibrium chapter, while you are writing pKa, what will write? Ionization of water. 2 moles of H2O gives rise and form H3O plus OH minus. Correct? Response are what we call it as self-ionization or autoprotolysis. What do we call it as? Autoprotolysis, or we call it as self-ionization of water. Correct? Response, sir. So for that, what you will write? Equilibrium constant K equilibrium is equal to concentration of H3O plus into concentration of OH minus upon concentration of H2O. I will not write square. Why? I will not write square. Why? This H3O plus I have to write as H plus H2O. Response, sir. So what I have to write? Correct or not? Response, sir. Okay. For your convenience, to avoid confusion, I am writing like this. Is there anything wrong now? Correct? So this is in liquid state. You will get H plus aqueous and H2O minus OH minus aqueous. Right? At a time t equal to 0, what is the concentration of H2O? 1000 by 18. What's the concentration of water? 1000 upon 18. According to Arrhenius, at a 25 degrees centigrade, according to Arrhenius, at 25 degrees centigrade, how many moles of water will ionize? 10 power minus 7 moles of water will ionize from 1 liter of water. Correct or not? According to Arrhenius, from 1 liter of water at 25 degrees centigrade, from 1 liter, 10 power minus 7 molecules of water will convert into 10 power minus 7 moles of water will convert into ions. Right? So from this, if 10 power minus 7 converted into ions, what I will write? 1000 by 18 minus 10 power minus 7, 10 power minus 7, 10 power minus 7. Correct? Correct or not? Then what is K equilibrium equal to? 10 power minus 7 into 10 power minus 7 divided by, I will write 1000 by 18 only. Reason? Compared to 1000 by 18 is 55.57. Compared to 55.57, 0.00006 zeros 1 is negligible. Correct? So I will write as 1000 by 18 only. So what this becomes? 1 upon 18, sorry, 18 into, that 18 goes to numerator, na? So 18 into 10 power minus 17. Correct, sir? This is K equilibrium of water. Right? Can I call this as Ka? Because you are getting H plus. Can I write as Kb? Because you are getting OH minus. Right? So what is Ka of water? 18 into 10 power minus 17. So what is pKa? 17 minus log 18, which is approximately equal to 15.74. So what is pKa of water? 15.74. Clear? This is what we believe it to be correct till 1952. Later, they corrected. While you are writing equilibrium constant, if anything is in excess quantity, what we will write? Or if any component is excess in quantity, what we will write? 1. You write it as 1 or not? If anything is excess in quantity, right? Response, sir, whose concentration doesn't change. For those terms, we will take it as 1 or not? Whose concentration is not changing here? This one. So denominator, what I have to write? If I write it as 1, what is Ka now? Then what is pKa? Right? As I am comparing the pKa value of water and methanol, in olden days, when they took that pKa of water as 15.74, right? And pKa of methanol is 15.5. Methanol, pKa of methanol is approximately, take it as 15.5, which is lower pKa. Methanol. That's why methanol is more acidic than water. Up to 1952. Later, when they modified that into 10 power minus 14, what is pKa later? Now, which is more acidic? Are you could understand? What is the mistake? The pKa, what they have calculated earlier is, in all our books, it is that only. In class also, in ionic equilibrium chapter, I also gave the same reason. After all, I need to follow whatever is present in our NCERT textbook. I should not do any modifications. I need to blindly follow whatever is present there. You need to read it. Otherwise, your marks in exam will be gone. Clear? Now tell me, among methanol and water, which is more acidic? Methanol, according to our. In reality, which is more acidic? That's differentiation. If you understand, that is enough. Leave it. Clear, sir? No. To avoid this confusion, they have not taken water into consideration in this question. Why they have not given water as one of the option here? If I give water, whether you have to give methanol or water, there is a confusion. A few people will say, sir, answer is water. Few people will say answer is. So to avoid that, they have avoided H2O itself completely. So now what is the answer, sir? Clear? Next question, sir. Question number 4. Carbocations may be stabilized by minus I or plus I. What minus I groups do? If they pull electrons, what happens to positive charge value there? If I pull electrons, what happens to positive charge there? Then stability.
Decrease.
So what option D will do? Stabilize or destabilize? Means option D is gone. Next. See ya. Perfect, huh? Why? See this. Correct. CH2 plus. Next carbon having CH double bond CH2. What we call this carbon as? Vinylic. And what we call this carbon as? Allylic. This is vinyl. This is allyl. Now, if I take this one, and if I have taken benzene, on benzene ring, if you have a carbon, then what we call this carbon as? Benzyl. Why allyl and benzyls are more stable? Because these pi bonds can delocalize, correct? Correct or not? So because of a pi bond delocalization, they will stabilize carbocations. That's why answer is pi bonds at allylic and benzylic positions will stabilize carbocation. Any questions in it? Come to next one. In the anion HCOO minus, they are talking about HCOO minus. The two carbon oxygen bonds are found to be of equal length. Why? This two, there are two carbon oxygen bonds, correct? This is one carbon oxygen bond. This is another carbon oxygen bond. Why these two bonds are having same length? Resonance, correct? Reason. This negative charge will shift here. This pi bond will shift here, correct? Then what you will get? This converts into HC, O minus here, double bond O here. What is the resultant of both? What is the resultant of both? Partial bond, minus 1 by 2, minus 1 by 2. Yes, sir. Correct or not? Right? Because that pi bond keep on delocalizing. So both have same bond length because of resonance or because of delocalization. So what should be the answer? Next question number 6. Which of the following resonance structure is the major contributor of resonance hybrid? Why? Correct. Very perfect. They are talking about resonance, right? Resonance means delocalization of pi electrons gives a different structure, right? First, I will give some basic principles of resonance, right? Before starting resonance, fundamental rule. How many times I have told? In chemical bonding, I told. While you are discussing about GOC also, I have informed this. What is the first condition for resonance? Before starting resonance itself, first thing we need to understand. Resonance in reality does not exist. It exists only in books. It is a hypothetical thing which is created by teachers and scientists to explain stability. In reality, it doesn't exist. First condition. Response, sir. It will be available only on books and on board. That's all. Clear? No. Leave that. Now come back. Resonance. Will you understand, sir? The meaning of it. Will you understand this or not? Right? No. During resonance, what should happen? Delocalization of what? Pi electron cloud. Maybe negative charge, maybe lone pair electrons, maybe positive charge, correct? Maybe pi bonds, etc. will involve in delocalization, correct? Response, sir. What about the relative position of atoms? What about position of atoms? Do atoms will change their position or they will not? If a position of atoms also changes, then what we call it as? Tautomerism. We also call it as desmotropism. Correct? Or we call it as tautomerism. Tautomeric structures are equilibrium structures. Resonating structures are canonical forms. Tautomers exist in reality. Resonating forms doesn't exist in reality. Clear? So what happens here? Relative position of atoms. Relative position of atoms. Changes or not? Do not change. Number of pi electron cloud. Or number of electron pairs. Number of electron pairs remain same. Number of electron pairs remain same. Now, I am writing like this. Listen, sir. CH3 C double bond O plus. And this oxygen is having lone pair of electrons. Now, do this oxygen can donate lone pair of electrons into this? Why? Oxygen have lone pair of electrons means oxygen have more electron density. Carbon is having positive charge means electron deficient. Do this lone pair of electrons present in 2p orbital of oxygen or not? Carbon's empty orbital is 2p orbital or not? Both have nearly same energy. Then oxygen can give that electrons into that empty orbital. Then what you will get? CH3, C, triple bond, O plus. Correct, sir? Now among these two, which is more stable? Which is more stable? Second one.
First one, sir.
Second one, sir. Reason. Condition 1. Condition 1. Neutral molecules are more stable than charged species. Condition 1. First condition you need to check whether given is neutral or not. If it is neutral, that is more stable. Condition 1. Condition 2. Condition 2. More the number of covalent bonds, more stable the species is. Condition 2. What is it? More the number of bonds, more stable the species is. We also call this condition as satisfied octet condition. What do you call it as? Now among these two, which is having more number of covalent bonds? Over. What we call it as satisfied octet. Reason, around this carbon, how many bonds are there? 3. Right? Means around that carbon, how many electrons are there? 6. Compare this case. Around this carbon, how many? 8 electrons. Means octet satisfied. Around oxygen also, how many electrons are there? 8. 3 bonds and 1 lone pair. Again octet. Correct? So in this, both are having octet, whereas here only oxygen is having octet, but not carbon. So due to satisfied octet, which is more stable. So while you are comparing stability of resonating structures, first condition what you need to check? Whether it is neutral or not. Neutral molecules are more stable than charged species. Second condition. If first condition fail, then only go for second condition. Then what do we have to do? Second condition. Satisfied octet. Species with more number of bonds are more stable. If that also fail, go to third condition. What is it? Opposite charges with minimum separation. Same charges with maximum separation. If this also fail, then check for next condition. Positive charge on less electronegative atoms or a negative charge on more electronegative atoms are more stable. So check these conditions step by step. Clear? This already I gave in identifying stability of resonating structures. Already we discussed these points, 4 points. What are they? First point. Neutral species are more stable than charged species. Condition 2. Satisfied octet. Third, condition 3. Opposite charges with minimum separation or same charges with maximum separation. If that also fails, condition 4. Positive charge on less electronegative atoms or negative charge on more electronegative atoms. If all the 4 conditions fail, then check whether it is aromatic or not. If it is aromatic, extremely stable. If this also fails, then crowding. What we call it as steric hindrance. Correct? Sir, we discussed these points or not? Say something. Steric hindrance. If steric hindrance decreases, stability increases. Clear? We need to check them in that way only. Right? Now come to this question. Which is more stable? Why? Satisfied octet. Katham. Right? Response, sir. Okay, I will stop the discussion here. One more thing. Listen. Up to March 8th, ma'am. Up to March 8th. Whichever topic you have doubts throughout class 11, you can ask. I will explain it in detail. Right? After March 8th, we will go to class 12th only for certain set of students. For remaining all students, again I will extend that up to 28th March. From 28th March, you should not ask me any questions on 11. So first stop is March 8th. till March 8th, whatever you ask, we will clarify the doubts of class 11th only. Right? Then one set of students we will separate, batch will start for class 12. Right? Then again, I will still continue clarifying the doubts of class 11th up to March 28th. 27th is the board exam completion date for state board students. That's right. So till March 28th, again, doubts only. 28th after, for all batches, only class 12th syllabus. That too, in chemistry, I will start with solid state, which is not there in your JEE mains portion, but it is present for advanced portion. Right? Solid state chapter doesn't require chemistry, math, pure math. If you have math, solid state is over. Pure math. We will not even discuss about chemistry, nothing, no chemical reactions, nothing, only pure geometry. Right? I will stop discussion now. And in next tomorrow also chemistry class is there. I will continue this topic. Right? Till all the electronic effects you are thorough. I will explain all the concepts, then I will close it. Another 40-50 questions we will solve and I will close it. Right. Hey, listen, one more thing. This is electronic effects, man. In that electronic effects, we will see acidic natures also. But we will continue. Right? It is a part of it. And if you want to read it in advance, then all the examples along with pKa values are given. Why I gave pKa value for every compound means for you have theoretical explanation, right? So whether my theoretical explanation is correct or not, we need to get confirmation. No? That's why you compare experimental data also. That's why for every compound I have given, pKa experimental value. But no need to remember that was experimental values. Theoretically, we need to give whether it is increasing order, decreasing order, most acidic, less acidic, only that data you need to identify. But while you are reading to compare, we are seeing that values to for comparison. That's all. Right? Response, sir. Here also, same thing we discussed or not? Why fourth one is most acidic? Why fourth one becomes acidic, more acidic? Right on. Time up. Huh? Why it is more acidic? More the number of -I, -M groups, more the acidic nature. So Ka increases, pKa decreases. Okay, like